Hi, so in today's probability video we're going to be looking at relative frequency. Relative frequency is really looking at experimental probability as opposed to theoretical probability. So in my previous videos I've looked at theoretical probability, so if I roll a dice I know I've got 6 different numbers, so I'm assuming that the chance of scoring each of those numbers is the same, which would be 1/6. When we look at relative frequency, that's more when an experiment has happened. So in this particular case, what's happened is we've got a dice and we've rolled it 100 times, and these are the results. So a 1 occurred 24 times, we've got a 2 16 times, a 3 8 times, and so on. So relative frequency is really just the word we use to calculate using this information to calculate a probability. And what the relative frequency is it's the frequency for each particular outcome divided by the total frequency, in other words the total number of times the experiment was carried out. So if I put here RF for relative frequency, we can calculate that for each one of these. Now I've kept it nice and simple. We're doing this 100 times, so all you have to do is each frequency divided by 100, and to divide by 100 you just, well, for all of these numbers we're just going to make it 0 point something. So the first one, 24 divided by 100 will be 0.24, 16 divided by 100, 0.16, and be careful with this one, 8 divided by 100 will be 0.08, 22 divided by 100, 0.22, 10 divided by 100, 0.1, and 20 divided by 100 will be 0.2. Now the total of all of these should be, if we've done our calculations correct, and we have, the relative frequency, if you remember the total of probability, the scale of it goes between 0 and 1, so if we're looking at any particular experiment or theoretical situation, all of the probabilities should add up to 1, and it will be the same for relative frequencies. So if you check those, the total of all of those together should add up to 1, and it does. So we can then use this to calculate probabilities, because if we've got a dice and we're using theory, we can say, well, the chance of getting a 5 on a dice is 1/6. But in this case, we've got a dice where we've carried that experiment out 100 times, so we can use that information to calculate probability. So the probability of scoring a 5 on this dice based on this data that has been collected would be 0.1. Okay. Now that's not a million miles away from the probability of scoring scoring a 5 on a normal dice, because it's 1/6, which would be 0.16 recurring. So the question is, based on this information, do we think the dice is biased? Now really, this is over to you. You decide and see what you think. Look at the probabilities. Is that what you would expect to happen? Because theory and reality don't always match up exactly. If I rolled a dice 60 times, would I get 10 of every single number? No, in reality I wouldn't. But how much would it take for you to be suspicious that someone had been messing around with that dice? So the question really is over to you. Do you think this dice is biased? And really I want to leave that for you to decide. Look at the numbers here. Do you think that, for example, the probability of a 3, the fact that that only came up 8 times, is sufficiently small enough for you to start questioning it? And I guess the next question is, how many more times would you carry out the experiment to be sure? Sometimes they ask that in exam questions, and actually the more times you carry out an experiment, the more reliable your data is. But essentially this is all you have to do. You calculate your relative frequency, and then you can find your probabilities. Your probabilities will just be the relative frequencies that you've calculated, but they do sometimes like to ask you some wordy questions like this as well. And really it's up to you to decide, as long as you can back it up with the maths that you've got there. You can say what you feel is the right answer. Okay, good luck.